Hi, my name is Ellie, and today I'm going to be guiding you through the polarization of light experiment. In experiment 1, we observed polarization effects in light scattered by small particles. Firstly, we'll be using a solution of Dettol. By moving our half-wave plate, we are able to change the angle of polarization, and we observe the intensity change over a range of 90 degrees. As you can see, the scattered intensity changes from maximum to minimum. In the second half of this experiment, we use an Ajax solution. As you can see, this solution scatters far less light than the Dettol one. In experiment 2, we're going to analyze the laser beam using a linear polarizer and verify Malice's law. We have a detector here which is connected to both the computer and our voltmeter. And here we have a linear polarizer. We're going to start off by rotating the linear polarizer so that we can find our maximum position. From here, we're going to take the intensity at every 5 degrees for 90 degrees and plot this. In experiment 3, we observed the conversion of linearly polarized light to circular polarization. We begin in the same setup as the previous experiment. We rotate our linear polarizer until we read a minimum intensity. From here, we then insert our quarter wave plate into the stand. The quarter wave plate is then adjusted until we receive our maximum intensity. Now, moving from this position in the linear polarizer, we're going to measure the intensity every 10 degrees for 180 degrees. For experiment 3, task B, we are converting the light to circular polarization using a circular polarizer instead of the quarter wave plate. We insert the circular polarizer in the stand and then adjust our beam orientation using the half wave plate until we receive a maximum. From here, we then reinsert our linear polarizer and adjust the polarization until we receive a maximum. From here, we're then going to, again, record the intensity every 10 degrees for 180 degrees. For experiment 3, task C, we're observing how circular polarizers affect reflected light. For this experiment, we are switching to the other side of the circular polarizer and rotating our detection arm around here. We add an aluminium mirror behind the circular polarizer to reflect the light backwards. The detector is aligned to catch this reflection here. From this position, we can observe the intensity of light from both side 2 and side 1. This is experiment 4 of the polarization of light lab. In this component, we will measure Brewster's angle for a glass prism in order to further determine its refractive index and confirm the direction of polarization of the laser. Brewster's angle is the incident angle at which light at a particular polarization will be perfectly transmitted through a transparent dielectric surface with no reflection. For task A, we mount the prism with its reflecting face along the center of the spectrometer table and rotate and tilt it such that the laser beam is reflected back along its path. The table position is then rotated approximately 45 degrees, and the wave plate is rotated to decrease the intensity of the spot on the screen. The table and wave plate are rotated incrementally until the reflected intensity is at a minimum. The table position and the wave plate position are then noted at this point. For task B, we measure the intensity of light reflected from the prism as a function of incident angle. We begin with vertically polarized light, and using the detector, we measure the intensity of reflected light every 5 degrees until the incident angle becomes too great to give a clear reflection. And so on. We then repeat this process with our wave plate set to give us horizontally polarized light. For experiment 4, task C, we set the half wave plate to give light polarized at 45 degrees and rotate the table so that the laser beam is incident on the prism face at 20 degrees to the normal. The analyzer, which is our linear polarizer, is then rotated to give minimum transmission from the reflected light. This angle is then noted down, and then we repeat the process with incident light at an angle of 80 degrees to the normal. The analyzer again is then rotated to give minimum light transmission, and the angle of the analyzer is noted. This is experiment 5 of the polarization of light lab. In this experiment, we will be measuring the polarization of a beam reflected from a metal surface when the incident beam is plane polarized. The half wave plate is rotated such that the incident beam is polarized at 45 degrees. It is then reflected off an aluminium mirror and through a linear polarizer and to a photodiode. Firstly, we align the mirror such that the light is reflected back along the beam's path. Then we rotate the mirror so that the laser is at 20 degrees to the mirror's normal. From here, we rotate the analyzer to give us a maximum reading. And the background intensity is noted. We then rotate the analyzer through 180 degrees, noting the intensity of light at every 10 degrees. We repeat this measurement with the incident beam at 79 degrees to the mirror's normal.